So now let's find the period and vertical asymptotes for some graphs. Right? So for some graphs of tangent, we're just going to do one period because the vertical asymptotes would repeat. For every period, we're going to have that same vertical asymptotes. So we're just going to find one period of the vertical asymptotes. To find the period, we take pi and divide by b. B is the coefficient on x. It's right there. So b is 1/2. 4 is kind of an amplitude. Amplitude doesn't have meaning for tangent, right? Because it doesn't have a maximum or minimum value like sine or cosine. So we don't really worry about it unless it's negative. We're only going to be dealing with period and the vertical asymptotes, and both of them only involve b. So if I take pi and divide by b, which is 1/2, dividing by 1/2 is the same as multiplying by 2. And this would be 2 pi. Now let's find the vertical asymptotes. We're going to set bx equal to negative pi halves and bx equal to pi halves, because that's where tangent normally has its vertical asymptotes. Changing the period will change the vertical asymptotes. So now I'm going to replace the b with 1/2. X equals negative pi halves, and 1/2 x equals pi halves. How do you get rid of the 1/2? Just multiply both sides by 2. So I have 2 times 1/2 x equals 2 times negative pi halves. 2 and 1/2 is just x. The 2's cancel, leaving negative pi. Same thing over here. So 2 times 1/2 x equals 2 times pi halves. 2's and 1/2 cancels, that's x. 2's cancel, and that's pi. So we have x equals negative pi and x equals pi are the two vertical asymptotes. And notice that if I go pi to the right and pi to the left, the distance between those is 2 pi. Let's find this one. All right, so we're going to find the period and vertical asymptotes of y equals tangent 3/2 x. To find the period, we take pi and divide by b. B is the coefficient on x, so b is 3/2. So that means the period is going to be pi divided by 3/2. Dividing by 3/2 is the same as multiplying by 2/3. I'll put that in front. Let me make that a little nicer. 2 pi thirds is the period. Now let's find the vertical asymptotes. Right, we take bx equals negative pi halves and bx equals pi halves, because that's where tangent normally has its vertical asymptotes. In this case, b is 3/2. So we have 3/2 x equals negative pi halves, and 3/2 x equals pi halves. How do you get rid of the 3/2? Of course, multiply by 2/3, the reciprocal. So let's get that x in there. So we have 2 times 3/2 x equal, 2/3 times 3/2 x equals 2/3 times negative pi halves. Somehow I always end up drifting to the bottom here. And then we have 2/3 times 3/2 x equals 2/3 times pi halves. Right, 2/3 times 3/2 will cancel, that's just an x. Here the 2's cancel, that's pretty nice, and we have x equals negative pi thirds. And I'm going to move that up just slightly because it's at the bottom of the screen. Oops. All right, move up. Oh, no! We don't want to see that. There. Normally I can move this all up at once. That's attached, so that's as far as I can go. That's I can't, I'm taping right now. Right, let's just move that up so you can see it. And let's do the same thing for the other one. You'll have to wait. All right, so the 2 and 3 will cancel. That's just x. Here the 2's cancel, and that's pi thirds. And so there's our two vertical asymptotes. X equals negative pi thirds, and x equals pi thirds. And notice if I go pi thirds to the right, and I go pi thirds to the left, the distance between those vertical asymptotes is 2 pi thirds, the same as the period. We're going to do 2 more. Here we have y equals negative 3 tangent 1/3 x. That 3 is important only because it's negative. So this graph is going to be reflected. It's going to go down left to right. All right, so, but let's find the period. The period is pi divided by b. I'm going to write a little bit smaller so I don't run out of space at the bottom there. b is 1/3. That means we have pi divided by 1/3. Dividing by a fraction is the same as multiplying by the reciprocal. So our period is 3 pi. Now let's find the equations of the vertical asymptotes. We take bx equals negative pi halves, and bx equals pi halves, because that's where tangent normally has vertical asymptotes. b is 1/3, so we have 1/3 x equals negative pi halves. 1/3 x equals pi halves. How do you get rid of the 1/3? Multiply by 3. So 3 times 1/3 x equals 3 times negative pi halves. 3 times 1/3 x equals 3 times pi halves. 3 times 1/3 cancels. That's just x equals negative 3 pi halves. And x equals positive 3 pi halves. And if I move 1.5 to the left and 1.5 to the right, the distance between is going to be 3 pi. So 1.5 pi to the left, 1.5 pi to the right. Distance between is 3 pi, and that's the same as the period. One more. We have y equals negative 1 plus tangent 2x. This one happens to be also shifted down 1 vertically. But that'll have no impact on our period. So anyhow, so let's find our period, and never would. A phase shift or vertical shift has no impact on period. So let's find our period, and then let's find our vertical asymptotes. So the period is pi divided by b. In this case, b is the coefficient in front, which is 2, coefficient on x. And that means that our period is pi halves. That's it. Nothing really to simplify there. Now let's find the vertical asymptotes. We have bx equals negative pi halves, and bx equals pi halves, because that's where tangent normally has its vertical asymptotes. Let's replace b with 2. We have 2x equals negative pi halves, and 2x equals pi halves. How do you get rid of the 2? You divide by 2, or since we have a fraction on the other side, let's multiply by 1/2. 1/2 times 2x equals 1/2 times negative pi halves. 1/2 times 2x equals 1/2 times pi halves. 1/2 and 2 cancel, that's just x. 1/2 times negative pi halves is negative pi fourths. 1/2 and 2 cancel. 1/2 times pi half is pi fourths. If I go pi fourths to the left and pi fourths to the right, the distance between them is pi halves, and that's the distance. That's the same as the period. And we've done it. We found the period and the vertical asymptotes for all 4 graphs. Thanks for watching. Bye for now.